A projectile can have the same range r for two angles of projection. Right. Now, what do you mean by this line? A projectile can have the same range r for two angles of projection. A lot of students might be knowing this, that it has the two angles of projection. But let us see how does we come to it. First of all, we'll require the general formula for range. If you do not remember, I'll tell you one short trick. Let us write it as total height t, range r, and maximum height capital H. Right? You might have learned that earlier. Girls used to say about boys that if he's tall, dark, and handsome, then the guy is very good looking. He should be tall, dark, and handsome. Tall, T stands for tall. R, let us suppose it is similar to D, basically dark, right, and handsome. Now what happens is you have to remember only this formula, which is of 2u sine theta over g, right? You just remember this one formula, because generally what happens is most of the students tend to get confused between the formulas of T, R, and H, right? So you have to remember only this formula using this trick. This is 2u sine theta over g. Now if I come to r, what will happen? This 2 will run over here. Now it is going over u, so that means it will become u square sine 2 theta over g, right? So we get this formula also, which is correct. Now again, if we move down, so what is happening? This 2 basically is moving from here to here, right? So it is going over u and sine theta. So that means h will have a formula u square sine square theta over 2g. So this was an easy trick. You just have to remember the total time, right? So the range is given by u square sine 2 theta over g. Now we know that. Now we come to the formula r equal to u square sine 2 theta over g. Now it is saying, this line is saying it is having two angles of projection for the same value of range, right? So that means if I put theta and the other value is 90 minus theta, if it is theta, then range will be u square sine 2 theta over g, and if it is 90 minus theta, it will become u square sine of 180 minus 2 theta over g, right? So sine 180 minus theta is what? Sine theta. That means u square sine 2 theta over g, right? So that means it comes out to be the same. That means the range is same for two values of angles, which is theta and 90 minus theta. That means, for example, if it is 30 degree, then the other angle should be 60 degree, so that the range is same, right? So that means the two angles are theta and 90 minus theta, right? So now let us see what it is saying. If T1 and T2 with the two times of flights in the two cases, then the product of the two times of flight is directly proportional to. Now time is given by 2u sine theta over g. That means T1 will be equal to 2u sine theta over g, right? And T2 will be equal to 2u sine of 90 minus theta over g, right? So this will become what? 2u cos theta over g, right? Now it is saying then the product of the two times of flights, that means T1, T2, this will be equal to what? If I multiply them, so what will be that? 4u square sine theta cos theta over g square, right? So I can write it as sine theta cos theta will be 2 sine theta cos theta. I can write it as sine 2 theta. So that means 2u square sine 2 theta over g square, right? Now what was the formula for the range? It was u square sine 2 theta over g. So I can again write it as 2 r square over g. Sorry, not r square, it will be 2r over g, right? Because r is u square sine 2 theta over g. So that means total time, the product will be 2r upon g. So that means then the product of the two times of flight is directly proportional to what? It will be r. So that means option A is correct.